Again, I'd like to thank you for taking the time to come out and invest in yourself by getting some more information and training. It only helps you down the road, trust me. I've been doing this a while. All right, so what we want to talk about today is the difference in performance and a little bit in cost on your sets of erosion controls that fall in the category of inlet protection, entrances or tracking devices, and perimeter controls. A lot of people only look at the cost of things. The cost is part of what you should be looking at, but you should also be looking at the sustainability, the potential reusability of the item. Some of them are, some of them are not, and whether or not you're getting good performance based on your inspections. If your inspections are showing you a failure every time you hit a rain event above a certain amount on that particular item consistently, then that is not a good BMP for your project, and you're not really saving anything. You're just building up a lot of maintenance issues, which could lead to compliance issues, and that's what you want to avoid. So, before we start, I'm going to go ahead and say this. Any kind of class always talks about erosion control and sediment control. Erosion control is anything we put down on top of the bare soil to keep raindrops from hitting it. It's our final cover of vegetation, grass, turf grass, rock, the pavement itself. That's erosion control. You're usually one and done. Sediment controls are where we put temporary barriers in place to try to allow the water and the sediment slurry to only move a minimal amount of distance while we're grading and building and doing everything. And we have to have both of them to be successful on construction, but sediment controls are ultra expensive compared to erosion controls. And you want to get away from sediment controls as fast as you can. So as soon as you get something graded and ready to go, get it covered. So, most often your SWIP inspectors are looking at these categories: inlet protection devices, construction entrances, perimeters. There's always a definition of something. An inlet protection device is designed to limit or manage the amount of sediment and debris that might be entering a stormwater drainage system. Devices may either filter the material directly, or they may interrupt the flow and allow gravity to drop out the heavier particles like sand, or they may be some combination of both. Inlet devices must not significantly block the flow of water, or they will cause ponding on a road, which could lead to a flooding issue. You need to look at that. If you have these types of devices, they can be modified, but you have to know what to look for. Either way, they require routine maintenance. Failure to do the routine maintenance kind of voids the warranty on these things, and they will fail. So, we're looking at low-cost versus medium-cost devices. Low-cost devices, such in the picture here, these are the plastic tubes with a geotextile on them, drain field pipes. A lot of people use those for curb and gutter protection. They will allow a limited amount of water to flow through them, but if you don't do the maintenance on them and sediment builds up and they have no overflow capability, they will start to cause ponding of water, pooling, and flooding. The better devices have built-in overflow capabilities and often are made of a reusable material. Like in this case, these are filled with recycled truck tire parts. They're very heavy. You don't have to weigh them down. 2 people pick them up, set them down, you're done. You can reuse them over and over and over. The inlet protection devices can be broken down into categories of materials that filter, things that interrupt the flow of it and allow gravity settling, or some combination. Examples of this could be as simple as a filter fabric cloth in a drop inlet, the inverted catch basin, sometimes referred to as a witch's hat, which is often used in post-construction to catch debris, leaves, etc., but can be used during construction. Both of these devices here are considered disposable. Aggregate, combinations of aggregate and wood or wire, again, you're allowing the water to filter through by making sinuous flow through all the void spaces, or perimeter controls used as inlet protection devices, in this case, silt fence. Again, the better devices have overflow capabilities or are more engineered for it. The gutter buddy or recycled carpet fiber devices can be very useful, but again, make sure that there is an overflow capability, because if these get saturated, they can sag into the curb inlets. You can introduce overflow capability by inserting a half of a brick behind it and allow that capability. So if you have those and you have no choice to use them, but that's what you've got, you can put in an overflow device by putting in like a half brick or a rock bag large enough that it won't go down the curb inlet as well. But you have to have overflow capability. If it suctions up next to the curb, it's going to cause a problem. In some cities, during the rainy season, they make contractors pull them out if they don't have the overflow capability, because they can't have flooding. No matter what, you cannot have flooding. Cost varies from something as simple as the filter fabric to about $1 a square foot to over $4 a square foot, a linear foot on some of these devices. The higher end ones, such as these, are often reusable, and the lower end ones are kind of disposable. Again, devices used to intercept the flow and allow for overflow capabilities are often better under high flow, high rain events. Again, this one has some capabilities to allow that water to overflow to this low spot, this kind of pinched waist in the middle of it. Better devices will always have that engineered into it, and you can see it in a number of different devices as we show some examples here. This one I like. This one is essentially a piece of PVC pipe with almost like a foam pool noodle on it, wrapped in geotextile, and it has these wedges that go up in it, but it has this clear spot right here, so this allows overflow capability, and it's capable of trapping a lot of debris and dropping it out and still not causing clogging or flooding. This device basically allows water to pool up and drop over, almost like a rock bag. This one is actually a granite inside of a very strong plastic netting that's strong enough to survive vehicles running over it, but again, it will stay in place and not blow out, and it positioned the way it is, it allows overflow. Even something as simple as rock bags, if you do them right, they're capable of performing well, but pretty much have a limited life. The bags don't last typically more than a few months before the UV breaks them down, so they're not really reusable in any lengthy period of time. Again, here's some combinations of one. Here is the same geo-hay materials used as inlet protection devices. Geo-hay originally was an artificial hay bale. It's made of recycled carpet fibers, and it does not require trenching. It kind of sags low to the ground when it gets wet. It's really good for that. It's a little less effective as an inlet protection device, but again, if you're aware of the need for an overflow modification to it, they can perform well as that. Here's some modified synthetic wattles. Some of these come with a stiffener wire in them to allow you to build angles on them and hold them in place. Some of them you have to modify and make a loop on them, like this one. This one is a plastic skeleton with a geotextile on it, and at the end it has space for you to put rock for weight, so it has kind of like a built-in rock bag, sandbag capability. These are all better than a standard. And there are even engineered devices. This one's a device called Silt Saver. It's a high-density polyethylene skeleton with a bag that goes on it. The bag has different flow rates and even has an overflow port capability and pockets around it to put aggregate in to weigh it down. It's while you're still grading and tying everything in before you get your manhole covers installed. The skeleton's reusable, the bag you replace, but the skeleton is also pretty good at supporting weight. They can hold over 300 pounds of weight on it. We bought a series of those on a project at Disney because of the fact that people come out to Disney World not always just for vacation. Sometimes they come out to sue people, hoping they'll get a lifetime free trip or something, and we had a concern that people would walk through a construction site and fall into one of these and contribute to the liability loss, so we purchased these at that time, and that worked well. There are also devices that can be secured to drop inlets that can be secured, some by magnets, some by straps. Some of them have a little bit of a riser port on them, but again, they have that overflow capability. So look for overflow capability in your inlet protection devices if you're looking for long-term, I don't want to have to mess with it. If you don't have overflow capability, you'll be doing a lot of repairs and maintenance on it. Again, these can be $2 to $6 per linear foot. The Silt Saver devices vary all over the board. I've seen them as cheap as about $40 a piece and up to $75, $80. Usually you get a discount when you purchase in quantities. Again, if you're going to go cheap, if you're going to use a silt fence as an inlet protection device, you need to understand the limits of it. Inlet protection devices can only handle about 1 acre of flow coming into them. More than that overwhelms them no matter what the device is. If you're going to use a perimeter control device like silt fence to protect inlets, you have to beef it up. The original specs for perimeter controls are to handle a 1/4 acre of runoff per 100 linear feet of sheet flow. Now I'm putting it 4 times more flow in a concentrated area. I have to make it work, I have to beef up the stakes and provide better bracing of it, or again, it will fail. So either there's too much acreage flowing through here, or they need to beef it up. Some combination of this results in this failure. When we look at our entrance devices, our anti-tracking devices, we're trying to manage and reduce the amount of sediment we track out onto the roads so that it serves a dual purpose. We're trying to control stormwater pollution, but we're also trying to make sure we don't contribute to vehicle accidents by making a slippery condition with sediment on the road. That can often be way more costly than a fine for a little bit of sediment pollution. You get a lawsuit on that. You'll still need to do maintenance. If you have tracking devices, you'll still have to clean the roads, but it should be a reduced frequency of the maintenance on that. So types of entrance and anti-tracking devices fall into the using aggregate or stone, some type of a metal grate system, or the plastic polygons, sometimes referred to as FODs. Those are some of the newer devices, and occasionally there's some other devices as well. I just kind of lumped that in there. So most of the federal programs are designed to use an aggregate construction entrance, and this typically is using a rectangular excavation with a geotextile fabric underneath the aggregate. The aggregate is usually a 2-inch stone, and usually you're doing a minimum of 6 inches of depth and, if possible, 50-foot length. That's to give a couple of bounces of the tires, and it'll shake off some of the sediment and trap it in the void spaces in the aggregate. It's expensive to bring in aggregate. In Florida, we don't have mountains near us, so it costs quite a bit of money to ship rock down to us. Even if you're in an area with an aggregate supply, if they're on the other side of the mountain, it may cost you quite a bit to ship it into that area. And here's some examples of some of the aggregate entrances that are better than others. Eventually, these clog up and completely fill up, and you have to dig them up and dispose of them. They're a one-time use, and they have quite a bit of a cost on them. The cost can be $6,500 to $8,000 for this device, from installation and delivery of the material to disposal in a landfill. That's a pretty big price, and on big projects you're going to have multiple entrances. There's a better choice. Metal grates, cattle grates, in this case this is called a rattle trap, have different purposes. Some of them actually shake the tires and cause it to drop in between the metal fabric. In this case, this device I actually bumped into the guy that developed it in California. This device is designed to flex the tires, so it doesn't shake the vehicles as much. It flexes the tires and causes sediment to drop out. Usually these are assembled in a group of 3. In 3, you have an entrance, a middle, and an exit. They do require a piece of equipment to pick them up. They are pretty heavy, but their service life is going to be 10 to 25 years, because all you're going to really be doing if they need maintenance is go to the welding shop, have somebody make a repair. Storage might be an issue for somebody, but again, at $6,500, $8,000 a pop for an aggregate one, these are going to be much more cost effective for you. You can rent some of these for about $250 per section too. So if you don't want to buy them or you don't want to store them, you can just go ahead and rent them. Depends on how you want to finance it. The plastic polygons, the FODs, those are some of the newer devices. They are a high structural plastic material that comes in segments, and again, they're usually they work better when you get a group of 3. I see some places that try to use just one. Again, it's kind of like you're sizing it a little short there, so you are going to have to be brooming the road a lot more. Make sure you follow the manufacturer's recommendations on what they have for you. But again, these devices both flex the tires and give a contact point for rubbing against the larger vehicles and scraping off some of the sediment. They trap it on there, then cleaning is either done by brooming it off of there or getting a laborer to push it off. You could possibly wash it off if it wasn't much. I don't think I've seen anybody successfully use like a leaf blower to get it off, because it's usually pretty thick on there and you're not going to do much with a leaf blower. But again, the cost range for these, purchasing 3, is $6,000 to $8,000 compared to the aggregate, and these are reusable. This is the way to go. The reusable ones are much more cost effective. You're not going to have to worry about doing some things on it. I'm not exactly sure how you'd make a repair on the plastic one, whether it's even doable, but they're fairly built like a battleship, so you'd have to really do something wrong to damage one, but anything's possible. Other devices. There are interlocking mats, usually made of either some type of a rubberized material or a plastic. The one on the right is called mud mats. It was developed originally for equipment to access golf courses without tearing it all up, so they could move some landscape or make a repair. It is a geotextile fabric with half pieces of bamboo cut into it, and it comes in a roll, and you roll it out. It is not a long-term device, it's just for short-term access. But let's say you finished a segment of a road and then had to come back and do a follow-up short-term work, and you didn't want to have to bring in the other things, you could possibly look at some of these. They're relatively inexpensive for their use. I don't have any cost range on the mat on the left. I think one of the vendors out here sells them. You could probably talk to him about it. Couldn't get everything. But again, the cost range, the mats are $1,200 for 4, so that's not too much for that. But again, they're short-term use. Short-term use. Again, just want to make this point, rock entrances cost you money, and if you're going to be doing this business for a while, instead of throwing the money away and not getting any recovery out of it, look into getting the reusable ones. Whether you go metal or go with the plastic ones, it's irrelevant to me. It's much better cost effective than to keep burying everything in the landfill, In some locations, they don't want anything buried in the landfill. Landfills are getting full. So take a look at these if they make sense for you. But again, most of these are pretty much 100% reusable. All right, perimeters. On perimeters, what we're trying to do are a couple things. First of all, perimeters are designed for sheet flow. They're not designed for concentrated flow. I can go pretty much anywhere in the country and see where they take a perimeter device, a silt fence, and then they try and put it in a concentrated area, a ditch, and it doesn't work. Why? Because it's not intended for that. It can't handle the velocity. So we have to have sheet flow, and we have to slow the water down. Many of the devices are to be trenched in. Not all of them require that. Some of them can be put in without a trench or a modified trench. Perimeter controls are weak. They only handle usually a 1/4 acre runoff per 100 linear feet, so they need help. So anytime you combine a perimeter with some other control, now you have a strong wall around your project. Combine a perimeter with some hydromulch, combine a perimeter with erosion blanket, combine a perimeter with some flow deflectors, redirecting things. Now you have a strong perimeter. Perimeters by themselves are weak. So here's a couple of different categories: silt fences, wattles, fiber rolls, and compost socks. Silt fence, again, is very commonly used in Florida. I don't know if it's as common here, but that's pretty much the #1 choice in Florida. Because we're relatively flat and we have a lot of sand, silt fence works well. Silt fence material has openings that do not stop small sediment particle size like clay. Clay will go right through it. So if you have a lot of clay washing off on your site and you're using silt fence, if you don't put some other combination of control on it, it's just kind of like a mile marker post as the muddy water is taking a journey down to wherever else it's headed. You won't really get a lot of control out of that. Most silt fence comes nowadays with either the posts attached or comes in a roll that you install later. You can have wood posts, you can have steel posts, T-posts, etc. How you install it and how you do the sectional binding together is important. When I started back in the 80s doing stuff like this, we used to do the overlap and staple method. We'd waste about 4 feet of fence and water would always get through it. So the better method now is to roll the 2 sections together and put them together. It's called lap, wrap, and roll. You only use about 1 foot of material and it's a solid seam, no gaps. Sometimes a second row of a fence can be effective. Especially in this case, they've combined it with some leftover remaining vegetation, what used to be a cattle field there. That can work well too. Always make sure that the posts are on the downstream side of the flow, because if they're on reversed, then the only thing you have holding up to the strongest force of nature, which is water, is staples, and it won't work. There's also wire-back silt fence, and this one's a flexible silt fence called a BSRF belted silt retention fence. It's high cost, but it outperforms a double row of standard silt fence. So you wouldn't put it everywhere, but if you had a low spot next to a wetland or an estuary that you wanted to make sure it had maximum protection, this would be a device to consider. The posts are very strong. It actually, the material has impregnated in it little pieces of fiberglass, and it will expand, and it's capable of holding back clay. So that's a device for that. Cost range for fences can be anywhere from 14 cents up to $2.15. Obviously, the higher cost is going to be for something like the BSRF, and the cheap silt fence is going to be that. DOTs are pretty good at not doing this, but I'm sure you've seen it on other projects. Don't let anybody ever use the silt fence you can see through that they pick up at Hughes Supply or something. I've seen that. You could literally hold a newspaper on the other side of it and read it. That's never going to work for anything. So make sure it's a good quality fence. If you pay for a higher quality fence, you will not be reinstalling it on a project that goes multi-years unless a piece of equipment runs over it. All right, other than silt fence, let's look at wattles fiber rolls. They can be made of natural materials such as straw or recycled materials. They can be artificial pieces of different types of discarded plastic, and we'll get into the compost in a bit. Most of these don't require you to install them in any kind of a trench, although in listening to John McLaughlin talk about all the different ways he's learned over the years to do it, there may be advantages to digging a small trench. So if you're just laying these things down, you're still seeing material escape, it might be time to look and see if there's a little hidden trick for making it better. I saw the way he was tucking in some of the rope and everything and overlapping. Those may be some techniques that may be more appropriate if you're using a lot of these devices and you're not getting success with them. The larger ones, they usually come in diameters anywhere from 8 inches up to 20 plus inches in diameter. Most commonly, people are using 8 to 12 inch diameter wattles, and they are capable of holding back several inches of material and allowing it to perk through. Some people prefer to stake through. I think I heard he called it the Dracula method, stab them in the heart. Some people cross brace them. There's different installation methods, etc. But a lot of times where you have a lot of foot traffic, these are more appropriate, where you have people coming and going and driving equipment over, as opposed to a piece of silt fence. People step over it and tear it, and it's not going to do any good at that point. Cost range for these devices can be anywhere from $2 to $3.50 per linear foot, depending on the fill and what diameter you're going to use. When you combine these with other controls, again, here's some with hydro mulch on it. Now I have a good effective control device. Here they are being used as flow interrupters to slow things down on a slope, as opposed to only having it at the bottom. Again, just emphasizing what I just said. With some hydro mulch, with straw alone. This is the weakest one here. These are stronger. Compost socks. There's quite a bit of interest in using compost because it has an environmental benefit. It actually promotes cleansing of a lot of the water and get a lot of biological breakdown in the discharges. The reason that a lot of the pollutants that we hear about every now and then become an issue is they don't break down. They wash things into the water, like plastic. They don't break down. They get in the environment. They stay there forever and ever. Compost already has the beginning of the soil ecosystem in it. And so once you expose it to some of these components that are coming off your construction site, it can already start the process of breaking it down and reducing it into something that nature can recycle. And especially when your final cover is vegetation, you can usually grab a hold of this, get established, and get going on for a better cover. Again, some of these devices, if you haven't seen them, compost differ from the other wattles in that usually there is a machine that will blow the compost into the tube. Some of them you can buy preset. They come in 8, 10, and 12 foot lengths, but a lot of times on a big site they're going to bring thousands of feet of tube and install it out there for you on a perimeter. And again, the cost ranges from $3 to $5 a linear foot. They're a little more expensive, but again, they're going to last you a long time, and they're going to survive for over a year or more on a lot of these sites. Again, these other work better when combined. Here they're blowing some straw on the uphill side of the project to reduce the amount of soil going to be dislodged by raindrop impact. So in summary, BMPs work best when designed as layers. Reusable BMPs will usually pay for themselves by the second use. Sediment controls are maintenance intensive. If you only stabilize and put your vegetation down at the last possible part of your project, you're missing opportunities. If there's any way for you to start stabilizing sub-basins and sections of it, that's the way to go. That will make it a lot easier. You've heard the phrase, how do you eat an elephant? One bite at a time. Don't try and eat the elephant in one big piece. You will not win. You'll probably have a tummy ache too. Erosion controls are usually one and done. Put down your final cover of grass, put down hydromulch with seed, blankets with seed. Usually, if everything's done right, you may have some minor maintenance, but that's it. That's usually it. You get what you pay for. You pay for cheap, you're going to be spending a lot of time and a lot of money on maintenance. If you pay for a cheap perimeter control that does not have UV inhibitors in it, it's going to break down in 6 months, start coming apart on you. That's usually going to be either when you're entering the rainy season or entering a dry season with a lot of wind, and you're going to start to see failures in something that was normally not an issue. So again, look for what's most cost effective for your project. If you're working a short-term project, you're only going to be there 3 months, you can go cheap. You're going to be there 2 years, 3 years, you're building a theme park that might take 4 or 5 years and cost billions of dollars. You don't want to be reinstalling a silt fence every 6 months. It's a waste of time, waste of money. So, where can we find more information? First can be the International Erosion Control. They have a great website. Just Google IECA. A lot of good information on that, a lot of good training sessions. The International Stormwater BMP database. This is a database that was originally just started out as the national one and morphed into the international one. A lot of good information, a lot of case studies. You don't have to read a lot on them. Again, bmpdatabase.org. Pretty easy for that one. Certified Inspector of Sediment and Stormwater Erosion Controls, CISIC. It's a good organization, provides some good training for that. Dr. Jerry Fifield's Field Manual on Sediment and Erosion Control BMPs for Contractors and Inspectors is a wonderful resource. Nice little book. It's printed on paper that can get wet. Keep it in your truck, keep it in your backpack for inspections. Little one sheet, cut sheet kind of information. It's a great resource. You're trying to explain to somebody how to go build something. You don't have to try to draw them a picture. You turn to that page and say, I want you to build this flow interceptor. I want you to build this check dam. Good information there. Also, your local erosion control vendors. All those guys out there at tables, they are wonderful. You have to get your controls from somewhere. It doesn't grow on a tree. These guys are designed to tell you and provide you with information so that you make the best choice possible. They want you to be successful. They don't want to sell you something that fails. They want to sell you something that works. Use them. Tap into them. Pick up some of their information. You can read it later. You don't have to memorize it. You could pick up one of their flyers and then 6 months later somebody goes, oh, our wattles are failing. What can we do? You can pull out the flyer and go, hey, we could look at these. Suddenly you look brilliant. All you did was pick up a flyer. That might make you more valuable to your company. Who knows? And that kind of concludes this. Does anybody have any questions?